All right, morning guys. Just going to teach you a quick lesson about graphing basic logarithmic functions. So we've graphed exponential functions before. We worked with logarithms. So I'm just going to teach you what a logarithmic graph looks like, and just some basic characteristics of it. So if you look at this graph, you see I put y equals log base 3 of x, right? Just made it up, no transformations or anything, just a basic parent function. What I'm going to do is I'm just going to put some x values and some y values in there, kind of see what it looks like. So let's think about some nice, neat x values maybe that we could put in. So you might say, oh, I want to put a 3 in there. Well, that'd be good because we know that log base 3 of 3 would be 1, right? Because 3 to the first power is 3, right? Or you might say, I want to put a 9 in there, right? Because I know that 3 squared is 9, so you could get a 2, right? So you get all these points, right? You could even put a 1 in here, right? What would that be? 3 to what power would give you 1? That'd be 0. And you'll notice this point's going to be a pretty prevalent one. And if you're really good, I mean, you might even put in like a 1/3, right? Because 3 to the what power is 1/3? Well, that'd be -1, right? Well, let's just take a look at some of these points and see if we can graph them and see kind of what we get. Okay, so let's say we graph the point 3, 1, right? 1, 2, 3, 1. There's that one. Okay, you graph the point 9, 2, 4, 5, 6, 7, 8, 9, 2. There's that one, right? Okay, 1, 0. There you go. And if you graph 1/3 -1, I mean that's not going to be very fun to graph, but it's like kind of right here. Okay, but you might say, well, I have no idea what this graph is going to do with all these points. Well, look, here's what happens. What it does is it kind of shoots up this asymptote. And by the way, this is going to be an asymptote. I'll talk about that in a minute. But it shoots up here and curves off to the right. Okay, so there's a couple things that are going to happen here. Okay, first off, the domain of this is limited. And you remember me talking, we can't have negative values for this x, right? Because there's no power of 3 that would ever get you a negative value, right? So what we're going to say is the domain for this function, the domain is basically from 0 to infinity, okay? From 0 to infinity. Okay? And the range is going to be all real numbers because you see it goes as far down as far up as you want, right? So, yeah, this is what a basic logarithmic function looks like. And notice this thing right here, you can't go past this line, right? So this actually has a vertical asymptote. And this is actually x equals 0. We're used to having the horizontal asymptotes at y equals something, but this is actually x equals 0. Now I want to show you a little trick. Watch this. Okay, here's a little trick. If you take this function right here, this logarithm, and you're like, man, I just really don't like logarithms. I'm going to take this logarithmic function. If you switch it to an exponential, you can actually get these same points. So watch this. The base is 3, right? So we say 3 to the y power equals x. So watch. 3 to the y power equals x. Okay? And this is a little tricky, but look. If you wanted to get some points on this graph, instead of putting in x's and get out y's, if you look at this, it'd actually be easier to put in y's and get out x's. So let's think about a real easy value for y. Okay, let's say you did 1, right? Well, if I put a 1 right there, right, 3 to the first is obviously 3, right? See that? And we get that point 3, 1 like we did before, right? You pick any value of y you want, and you can get it because the range is all real numbers, right? So any value, you put a 2 in for y, right? You get a 9. And all those points that we just got, you could get, right? Okay, so there's a basic function, right? Now, I want you to understand something here, okay? This graph right here is very similar to something we've seen before. Remember when we graphed exponential functions, right? When you graph exponential functions? Well, an exponential function, I'll just graph this one real quick. An exponential function, remember, looks kind of like this, right? Where it has a domain of all real numbers and a range of y is greater than 0. But if you look, basically, it's a reflection of this line y equals x, because what happens from here to here is basically just the x and the y's flip, okay? So I want you to understand that when we're graphing logarithms, they look eerily similar to exponentials, right? But one has a domain of all real numbers, the other one has a range of all real numbers. Basically, the domain and range flip, and they get flipped over this line y equals x, okay? So I just want to graph one more with you, see if you guys can kind of stay with me here, but I just want to graph one more logarithmic function with you guys, and we can kind of take a look at what it looked like, right? So let's say we had y equals log x, right? Y equals log x. And we want to graph this, right? We might say, Mr. Winslow, this doesn't have a base. Well, of course it has a base. This is called the what? That's right, it's called a common log, and it's got a base of 10, right? So it's got a base of 10. So if you wanted to do this, if you wanted to do that little trick I taught you, here's what you can do, okay? The base here is 10. The exponent is y, and the answer is x, right? So we can say 10 to the y equals x, right? So let's make a quick xy chart, right? What's the value for y you want to put in? Let's say 1. Let's do 1. Well, 10 to the first would be 10, right? And you could see that log 10 equals 1 because 10 to the first power is 10, right? Well, you can see this one gets really big quick. If I put a 2, you get 100 out, right? What if I put a 0 right there for y? What's 10 to the 0 power? Well, it'd be 1, right? And what if I put a negative 1 in for y? What's 10 to the negative 1 power? 10 to the negative 1 power. It's not negative 10, remember, it's 1/10 because it just flips it, right? So all I have to do is graph these points, and look, you're going to see a very similar graph to what we had before, okay? So let's say I apply the point 10, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, you got it right there, right? 10, 1. 102, I'm not going to graph that one, but it's way over here, right? 102. 1, 0, you notice that 1, 0 is always going to be on there, right? Unless we transform it. We'll get to that tomorrow. And maybe you went 1/10 negative 1, that'd be like right here. But look, it's basically got the same shape as it had before, right? You got this little graph like this. Okay. What's the domain of this graph? Well, the domain would be x needs to be greater than 0, right? So you could write x is greater than 0. You could write 0 to infinity, whatever you want to write, right? Okay. And the range of this graph, since it goes down and up, would be all real numbers, okay? See that? And don't forget, we have an asymptote at x equals 0, right? So, some of y'all are like, hey, Mr. Winslow, this is all well and good, but can my calculator show me what this looks like? Yeah, your calculator can show you. And of course, your calculator likes base 10s, base e's, right? So you could go and graph a logarithmic function on your calculator. But let's say it didn't have a base of 10 or e, right? Let's say you want to do that first example on your calculator. So you want to graph y equals log base 3x, right? The way you would need to type this in your calculator, if you went to your graphing window, you would type in y equals log x divided by log 3, because for our calculators to understand it, we want to do the change of base form, right? So you could, if you ever got a base that wasn't 10 or e, you could graph it just like that, and you would get all your points and everything. So my main goal for you today is just to be able to graph a basic logarithmic function, give me the domain, range, the asymptote, and then we'll get into transformations tomorrow. So just understand that these are just inverses of the exponential functions, and you're going to have a few homework problems, so make sure you check e-class. But that's it for today's lesson. I hope you guys enjoyed it. See y'all later.